Okay, so we have notes. Chapter 1, Section 2, Day 1, Analyzing Graphs of Functions. We're starting with find the domain and range using the graph, and you have the graph. So we're going to start with the domain, and we know that the domain is always talking about the x-axis. So to find the domain on the x-axis, it's always the x-axis. For both, you always go smallest value to largest. So we're going to start all the way to the left of the x-axis where the smallest values are. And I always start with my pen and I go along the x-axis until I see the graph begin. I see an x value. Well, there's an x value. The graph began. So on the x-axis, I'm going to mark this point. That's a closed dot, so I'm including that point. So I'm going to mark that on my x-axis with a bracket. And that indicates that I'm starting an interval on the x-axis for my graph. So for x-axis, always keep my pen on the x-axis. I'm translating or mapping the graph onto the x-axis because that's all the domain cares about. Does it exist on the x-axis? And that's the question I ask in my head. Does the graph exist? Yes, it does. Does it exist? Yes, it does. Does it exist? Yes, it does. Until I get to this, there's a significant point. That is an open dot. There is a gap in my graph. An open dot means it does not exist, so I need to mark that on my x-axis. I use parentheses to mark a stopping point because it goes up to that point and it stops, and then it starts again just on the other side of that point. So I'm going to do another set of parentheses going the other way. So I have the first interval, it stopped, it immediately started again, and now I keep going. Does my graph exist? Yes, it does. Yes, it does. Yes, it does. Does it exist? It keeps existing. There's graph there. There's no breaks. And then I see an arrow. I know an arrow means it keeps going on forever. Forever would be to infinity. And I'm going to close that interval. And infinity always gets parentheses. So I've mapped out the domain on my x-axis. And now I can write it officially over here for domain. So I see I started here at that point -4, and it's a bracket, so I'm going to start with a bracket at that point -4. And then I need to see where does this interval end. Well, at the next point that I marked is parentheses, and it's at the point -1, -2. So -2, I stopped that interval. I did not include -2 because it's an open dot. And then I need to start a new interval. So I'm going to use this U for union. It's my connector. I'm connecting these two intervals together because it's the same graph. And I'm going to start it again at -2. But -2 is not included. It's just on both sides of it. The next marker where I marked to close that interval was all the way over at positive infinity. So it's going to go to positive infinity. Infinities always get parentheses, never brackets. And your numbers always need to be in order from smallest to largest. If they're out of order, it doesn't make any sense. Right? Logically, it just would not make sense. So that was domain. You could also use inequality notation. I will always use interval notation because I prefer it. But we could also write this as our starting point was -4. The bracket means we're going to use less than or equal to because we're including. Domain is always x values. The next point was -2. It is not included, so less than -2. And then you can write the word and or use the and symbol instead of the union. And then we have from -2 to infinity. So the simplest way to write that is x has to be bigger than -2. There is more than one way to write this correctly. This is just the first way that comes to mind for me. You could say x is greater than or equal to -4 and then do an exclusion, but it does not exist at -2 if you want to get fancy with your set notation. But and you could write this a different way. But mainly, I'm going to use interval notation. I find that to be the easiest, especially with this mapping it on the x-axis method that I do, because then it's the same thing, bracket, parenthesis, 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 bracket, parenthesis, parenthesis, parenthesis. So it matches. That's why I'm calling it a map. So next is range. I'm going to map the range on the y-axis from smallest to largest. Smallest y values are down here at the bottom. So range is always bottom to top. Do the same thing. I'm going to start all the way at the bottom and go up until I see a value, a y value on my graph. There's a first point of the graph, so that y value is where the range begins. It's closed, so I'm going to start with a bracket. And then I'm going to continue up. Is there a y value on my graph somewhere? Yes, there is. Is there a y value on my graph somewhere? Yes, there is. It's still going. It's lots of three y values right there. That's fine. Just as a simple yes or no. Does the graph exist? Is there a y value? Yes. Is there a y value? Yes. More than one. And then up here at 2, I see I have a bubble in my graph. So there's no y value right there. However, there is a y value right here. So is there a y value? Does a y value exist? Yes. So I don't mark that because it does exist over here. Just because it doesn't exist over there doesn't mean anything if the one exists over here. So it keeps going, and then I have an arrow pointing up. So it's going to go forever to infinity. There's only a single interval for my y's, for my range. So then I can write my range. Smallest to largest, start at the bottom. It was a bracket. -5. And then from -5 goes to infinity. Infinity always gets parentheses. Or I could write this in inequality notation, since it's pretty simple. The biggest thing with range in inequality notation is you must call it y, not x. Because range is always y. In this case, it's greater than or equal to -5.